Hello everyone. Today we will see how do we implement isolation. Isolation is one of the asset properties used to ensure data consistency and integrity. What does it say? It ensures that the transactions are executed independently without interference, preventing issues like dirty reads, non-repeatable reads or phantom reads. You have seen when we say dirty reads, you are reading an uncommitted data which is modified by one transaction by the other. So, due to which in case if it aborts, you have to go for cascading aborts even in the case of second transaction, or otherwise in case if that commits, it is a dirty value, that means which does not exist in the database at all. Such problems, or when we say phantom reads. Phantom reads are again going to be the situations where you are executing a query and in between another transaction has updated a value so that this query, its value or data modifies. So, when you are running it again in the previous transaction, you get a different value. So, it is like your inconsistent reading where you are going to read a data repeatedly in one transaction. In between these two reads, another transaction has modified that value. So, you are getting inconsistent values. Such situations can be avoided when we go with isolation. So, isolation ensures that concurrent transactions are executing parallelly, but as if they are independently or serially executing. So, it ensures that one transaction is invisible to the other. It is executing as if it is only one transaction running, or more clearly we can put it as through isolation you will ensure that one transaction is hidden from the other as long as it completes or commits if it is affecting the common data. So, when I talk about this, there can be different isolation levels ensured or applied. So, isolation level define the degree to which the transaction must be isolated from the data modifications made by other transactions in the database system. Like in what level do you ensure isolation? If you are going for a high level of isolation, it can guarantee system consistency but reduces the performance because concurrent executions may get affected little bit. Whereas low level, that can give you the guarantee of concurrent execution but data inconsistency may occur. So, you have to see the situation based on your application. So, the SQL standards define 4 levels of isolation to balance between data consistency and system performance. They are serializable, repeated read, read committed and read uncommitted. Let us see one by one. Serializable. It is high level of isolation, highest level of isolation, ensuring complete isolation from the other transactions. That is, it appears as if the transactions are executed one after the other serially. So, serializable executions define that it is an execution of operations in which concurrently executing transaction appear to be serially execution. So, this is highest level. So, trade-off. When you are talking about the benefits or the advantages, you can be assured of consistent and serial execution, but the performance may reduce little bit. Okay, we will see how it is implemented or why it is going to be reduced. Next comes repeatable reads. This is a most restrictive isolation level where each transaction holds locks on reading each row for reading as well as write locks on each row for all the rows for insertion, updation and deletion, that is modification of your database. Since other transactions cannot read, update or delete these rows, it avoids non-repeatable reads. That means when one is accessing, all others have to wait. They cannot access or they cannot repeat that, read that particular data. Coming to read committed. Read committed, when I say, this ensures that every transaction is committed before it starts reading. So transaction can only see the changes committed before it starts. That means as soon as it completes access, it has to be committed, so that another transaction, when it reads, it will read only the values which are committed and which don't have the chance of getting modified again. Okay, any data that is committed immediately after its access. Now here this isolation allows only committed data read, so no chance of dirty reads. That is one transaction being read immediately after other transaction has updated even before it commits. The transaction hold a read and write lock on the current row and thus prevent other rows from reading and updating or deleting it. So here in the earlier case you saw that it on all the rows it holds. So no other data value can be updated. Whereas in case of read committed, it holds a lock only on that row or only on that particular data, so other data can be modified. Read uncommitted says the transactions may see uncommitted changes by other transaction, which is your dirty read case. It allows dirty read, lowest level of transaction, so it may read not yet committed changes made by other transactions also. So that means it allows dirty reads. Now you may wonder, why should I have when it is not assuring, why should I have it? That is because you have to see the trade-offs. You have to see the cost or overhead incurred. When you talk about the higher level of isolation, you have stronger data consistency, but it may result in long lock times. That means one transaction is holding the lock, because of which there will be contention for that particular lock, or otherwise you want to apply lock on that particular data which is being accessed or modified by the other transaction. You have to wait, and meanwhile so many other transactions may join, there may be contention for it. So this may lead to a decreased concurrency or the performance. But I can be assured of consistency and I can be assured of serializability, but it may affect your performance. Whereas lower level may provide you more concurrency, but data inconsistencies may also come in. So that is why the choice of isolation level depends upon the specific requirement of the application. What kind of application and what kind of implication you will have based on your data reversals. So it has to take that particular time and you have to take a decision based on that. Okay, fine. We understand that there will be different levels of isolation, and isolation can be performed through locking mechanisms or time-based protocols. In case of locking mechanism, locking ensures exclusive access to the data item. Whenever you have to access the data item, you apply for the corresponding lock. This means that while one transaction holds a lock on a particular data item, the other transaction cannot access that. Okay? Whereas timestamp based protocol does not use locks, but instead it uses a concept of time start. Whenever a new transaction starts, it will be associated with the new timestamp which is increasing in order, and generally it can be a system clock or anything. So the timestamp determines the order of execution of the transaction. That will ensure older transactions will always get priority. So there is no starvation or deadlock, but without applying for lock, based on timestamps you will decide which transaction has to work. Okay. So first we will try to see the locking mechanism for implementing isolation. When I say locking mechanism, the locks will ensure, why should we go for lock? Okay, it can ensure consistency. That is, without locks, multiple transactions may access and could modify the same data, leading to data inconsistency. So if I say isolation, yes, it can ensure, because you are locking, the other transaction cannot access, so only this transaction will be accessing. That means it is working in isolation, it is hidden from the other transaction. Concurrency, because you have locking, if you are not modifying, if there is not going to be any conflict, you can allow the transaction to run simultaneously. So concurrency will improve performance. Only when you are modifying common data, you ensure lock. Otherwise, two transactions can run independently, parallelly. So that can increase or assure concurrency. So avoiding conflicts. We have seen the write-write or read-write conflicts which occur when we are executing transactions concurrently. Now by applying lock, whenever there is going to be a conflicting pair, you ensure that you apply lock and release the lock only when you have updated, so that the other transaction can read the updated data only. So that can avoid conflicts. Finally, it can prevent dirty reads. This is again because of that only. You will ensure prevent reading uncommitted data. Okay? Fine. Coming to the locks. How many types of locks are there? Basically, it defines two types of lock. One is a shared lock, or I call it as S lock. The other one is an exclusive lock. Shared lock is used for read purpose, and exclusive locks are used for both read and write purpose. So just look at this. The lock allows the transaction to read a data item. So multiple transactions can hold the share locks because all of them reading together does not affect the data item at all. That is why we called it as a shared lock. It is denoted by lock S, or is called as your read lock. Exclusive lock allows the transaction to read and write the data. Now here you remember, if a transaction holds an exclusive item, lock on an item, no other transaction can hold any other locks. No exclusive lock nor read lock, shared lock on that same item. So it is denoted as lock X, or it is called as write lock. So what is the difference between the two? Remember, shared lock is used for reading purpose, exclusive is used for read and lock. Shared lock, simultaneously multiple transactions can hold shared lock on the same data item, whereas in exclusive only one transaction can hold exclusive lock on an item, on a particular item. Okay. So well, this is about the different types of lock. How using this lock based protocol I can ensure isolation, we'll see in our next video. Thank you.